That's true. It could be because of the man-made disaster.
Yes.
Good point. The Raja's ministers implored him, "Your Highness, let us open the royal storehouses and give the rice to the people as you promised." "No," cried the Raja. "How do I know how long the famine may last? I may not have enough rice for myself." Promise or no promise, a Raja must not go hungry. Time went on, and the people grew more and more hungry, but the Raja would not give out the rice. Was the Raja, was he wise and kind?
No, he was wise. He was maybe wise, but not kind.
You think maybe maybe
no,
wise?
probably not, because he's probably going to rebel against him or something like that.
What'd you say?
It's not wise for like not helping his people.
Yeah.
Because without his people, he's not king. If there's no people, he's king of nothing.
One day the Raja ordered a feast for himself and his court, as it seemed to him a Raja should now and then do, even when there was a famine. A servant led an elephant from the royal storehouse to the palace carrying 2 full baskets of rice. A village girl named Rani saw that a trickle of rice was falling from one of the baskets. Quickly she jumped up and walked along beside the elephant, catching the falling rice in her skirt. She was clever, and she began to make a plan. What do you suppose her plan is?
To get the rice each time he carries it.
To what?
Something like that.
What'd you say?
She's going to collect the rice each time.
And do what with it?
Eat it.
Eat it? Okay.
Maybe give some out.
Give some away to, who do you suppose she might give some to?
Family, friends.
Okay. As the palace guard watched, he cried, "Halt, thief! Where are you going with that rice?" "I'm not a thief," Rani replied. "This rice fell from one of the baskets, and I'm returning it now to the Raja." When the Raja heard about Rani's good deed, he asked his ministers to bring her before him. "I wish to reward you for returning what belongs to me," the Raja said to Rani. "Ask me for anything, and you shall have it." Is this the plan that you thought she would have?
She's going to ask to give the rice to the people.
What do you mean she's going to ask to give the rice?
Like she's going to ask him to ask the Raja to give all the rice to the family.
So she's just going to outright say, "Give all the rice to the people since there's a famine?"
Or give me a share of it eventually.
Okay.
Maybe like rice.
"Your Highness," said Rani, "I do not deserve any reward at all. But if you wish, you may give me 1 grain of rice."
She's going to grow it or something.
"Only 1 grain of rice?" exclaimed the Raja. "Surely you will allow me to reward you more plentiful, as a Raja should." "Very well," said Rani. "If it pleases your Highness, you may reward me in this way. Today, you'll give me a single grain of rice.
Oh.
Then each day for 30 days, you'll give me double the rice you gave me the day before. Thus, tomorrow you'll give me 2 grains of rice, and next day, 4 grains of rice, and so on for 30 days. Now that if you know the day number and subtract 1 from it, use that as the exponent, and the base of 2, you get the number of grains received on that particular day. So we can try this out to see if it really does work. If the day number is 1, base number of 2, day number of 1, and subtract 1 from that, so we end up with 2 to the 0th power, which is equal to 1. So far it seems to work. Let's try it on the next one. The base number of 2, the day number is 2, subtract 1. We have 2 to the 1st, which is equal to 2. Here, if the day number is 3, subtract 1. Use that as our exponent. We have 2 to the 2nd power, which is equal to 4. So far it seems to be consistently working. And one last time here, if the day number is 4, subtract 1. We have 2 to the 3rd power, which is equal to 8. So, understand. So the next step would be to have them use a spreadsheet to do basically the same thing that I just did with this data table or T-table. Okay, so I introduced them to Microsoft Excel, and I introduced them to the idea of being able to create a spreadsheet that does the computation for them. So here I've got a spreadsheet created, and the the columns are titled days, number of grains, and total, and we go up to the 9th day on this illustration. The formulas that are used are going to be inserted later after we have been able to type the values in by hand. So once we see the pattern and are able to express it, we can then type the formula in that does the computation for us. Walks them through the process of setting up a spreadsheet that will be on their handheld graphing calculator that does the same thing as what I just showed you Excel spreadsheets can do. And so at this point they've got the column here for the day number, and here they've got a column for grains of rice received on that day. And after they're finished following these instructions, they would have the expression, the algebraic expression that I showed you earlier on the T-table, and then again on the Microsoft Excel spreadsheet. And now they're seeing that they can do basically the same thing with a calculator that they can hold in their hand and carry with them on site, solving other problems where carrying a computer along might be awkward. Field 1 here, named day number, and it's been defined as a number. Field 2 will be grains received, 2, and it's going to be raised to a power that's equal to the day number, and then we'll subtract 1. Now notice there is no parenthesis involved in the exponent, so the base of 2 is going to be raised to the power that's equal to the day number, and after that's done, then the subtraction of 1 will occur. And the numbers... when they encounter a difficult problem, one way to approach it is by writing the information down in an organized way. I chose a T-table in this case. And then using the technology that we've got available to us to do the computation so that we can check to see if our predictions of an expression that would satisfy each one of these particular values works, can be done pretty quickly with a graphing calculator, with Microsoft Excel, and now with Inspire Data. And once they've got it in those formats, then they can go about producing the graphs that represent that information in such a way that they can look at it and see, oh wow, exponential growth is pretty significant and it's pretty rapid, and where else might this occur other than this story, 1 grain of rice? So we can talk about other possibilities of where they can express a growth rate in such a way mathematically that they can make predictions about how much of that thing or whatever it is there will be at some point in the future. One place where this turns up is in a discussion about DNA and how DNA is replicated. You start out with a double helix, and that double helix unzips, and then each one of those sides of the ladder is replicated, and you end up with 2. So there's a doubling